Alright, this video will go through how to find the inverse of a function and how to use the inverse of a function for various things. Alright, so here's an example of a simple function, and we're going to take the inverse of it and think about what that means. So a contractor charges some base cost for materials and then a cost per hour. And we've seen this type of thing before, right? This is a basic linear function. So we can say P of T, the price that the contractor is going to charge, is given by 30T plus 120. And so if we wanted to figure out the price, for working for 2 hours, we would plug in 2. And that would give us 60 plus 120 is $180. Right? That's the price that we would pay. Now, maybe we're interested in figuring out the opposite. We're budgeting or something like, so if I have $200 to work with, how much labor could I get? Or, things like that. We want to figure out the reverse of this. Instead of plugging in a time and getting out a money, we want to plug in a money and get out a time. So what we could do, let's see, if I think of this as, let's just call it like P instead of P of T, right? Let's give it a variable name. What I could do is I could solve for time, right? So how would that work? Right, I could take away 120, and then that would give me P minus 120 equals 30T, and then I could divide by 30. And so now, right, I kind of have it reversed so that I could plug in a price. So let's just say, how much labor could I get for $210? Well, so I could plug that in. 210 minus 120 over 30, that would give me 90 over 30, and so that's going to give me 3. Now, the result here, right, is in hours, whereas before the result was in dollars, right, as a price. And so by reversing the function, we've reversed the role of the input and output. Instead of plugging in time and getting a price, we plug in a price and we get a time. Okay, so this idea we call a function inverse, or the inverse of a function. And the best way to learn it, to sort of have the definition in your mind, is an inverse reverses what the input and output do. And we're going to see that theme as we go through this. Anytime we're trying to figure out what an inverse does, we're going to do what we normally do, but backwards. Okay, we use this notation. So this is read F inverse. You don't read that as an exponent. If you wanted to make it an exponent, you'd have to put it on the outside like this, but we're not really going to look at that. Okay, so it's pronounced F inverse of x, not f to the negative 1. It's not indicating to take a reciprocal. And again, we should know how to do it with a table and a graph and an equation. So looking at a table, right, normally if I said find f of 7, well, you would go to your x, okay, 7, and you would get your y value. So now if I do f inverse of, let's just say, like 9, okay, so right, normally we plug in an x and we get out a y, but the inverse switches things, so now we're going to plug in a y and get out an x. Okay, kind of like before when we plugged in a time and got a price versus when we plugged in a price and got a time. So I would go to my table, and instead of plugging in an x coordinate and looking up a y, I go backwards, and so the answer would be 10 in this case. I could, in fact, just write the entire table for f inverse if I wanted to. And all I would need to do is switch the coordinates, right? So the x coordinates become the y coordinates and vice versa. And some students find it helpful to just write out the whole table if they need to. Right, and so now you can look at it this way, is like I plug in, this is my input and this is my output. That's another way to say it. All right, so table, it's very straightforward. With a graph can be a little trickier, but we know what g of 1 means. All right, go to my graph, plug in 1, and get out -1. Right? If I were being asked to solve g of x equals 1, that would be a different question. That would be, right, I don't know the x coordinate, but I do know the y coordinate. And so I can see that answer would be 3. Okay, so now g inverse of 1 is going to do the opposite of what g of 1 did. So here we plugged in an x and we got out a y. Now we're going to plug in a y and get out an x. That's actually the problem we just did. Okay, so these are two ways of saying the same thing. To set g of x equal to 1 and solve is the same thing as finding g inverse of 1. Because when we plug in that y coordinate, we're going to get the x coordinate of 3. So those actually have the same answer. And likewise, okay, when we did g of x equals 1, we didn't know the y coordinate, or sorry, we didn't know the x coordinate, but we did know the y coordinate. Okay, so now it's going to be backwards. We don't know the y coordinate, but we do know the x coordinate, right? The inverse does the opposite thing. And so if the x is 1, then the y is -1. Okay, so this is actually the same question as this. Okay, so just take some time to get used to the symbols and what they do, but think about what you normally do and then just do the reverse. All right, and finally with an equation, okay, to find the inverse of something, we switch x and y, right? We've been saying that. Okay, so we're actually going to do the same thing with this. Remember, f of x can stand for the y coordinate. So I'm going to start by rewriting it like that. And what I will do is literally switch x and y. All right, and solve for y again. So I will start by adding 5 to both sides, and then divide both sides by 3. And we'll just leave it as a fraction like that. What I find is f inverse. And so that would be my final answer. Okay, and if we look, we can see, here we multiplied by 3, here we divided by 3. Here we subtracted 5, here we added 5. Okay, so a lot of times that's going to happen with an inverse. It's going to sort of undo the operations. So multiplication becomes division, etc. Okay, we can always do the process I just did. We can always switch x and y and try to solve for y, but only sometimes is that going to produce another function. Remember, a function has to pass the vertical line test. All right, so like this is a function because it passes the vertical line test, but this is not a function. Now, sometimes you can have something that's a function, but its inverse is not. Okay, and the classic example is x squared. That is a function. However, if you were to take its inverse, right, let's switch x and y and solve for y. Remember, when you take a square root, you need to take a plus or minus, and that graph looks like this, okay, which we just said fails the vertical line test, so that's not a function. This is a function, but this is not. Okay, so how can you tell? And the easiest way is simply, to look and see if it passes the horizontal line test. Okay, is it a one-to-one function? Any function that is one-to-one will also be invertible. Okay, so like this is x cubed, which is 1-to-1, and the inverse of x cubed is the cube root of x, which looks like this. And although it does go vertical here for an instant, it does pass the vertical line test. Okay, so a function is invertible if and only if its function is also an inverse, or its inverse rather is also a function. Okay, one other thing that you'll be asked to do sometimes is to graph the inverse of a function. This looks a little intimidating, but it's a simple idea. Again, we are going to switch x and y. So the coordinates are simply going to switch around. Okay, in other words, if 5, 3 is on the original graph, then 3, 5 will be on the new graph. And we can see, like, on h of x, 2, 4 was a point. So on the inverse, 4, 2 is going to be a point. And, this one, like 1, 1, of course, when we switch the coordinates, it doesn't move. When you do this, the graph of an inverse will always be a reflection over the line y equals x, which is why I've drawn that diagonal line there. So it's kind of a way to check your answer. It should be like a mirror image across that line, kind of like you did in geometry. Okay, so just an example of how to do this. If I were asked to sketch, let's call this f, the inverse of f, what I would do is identify some coordinates that are easy to work with. So, this would be an easy one, 1, 0. Let me use a different color here. Okay, would give me the point 0, 1, right? Just literally switch the coordinates around. That's all you got to do. And then this used to be, 4, 2. So now it will be 2, 4. Okay. And then, you can just try to mirror the behavior. So this it looks like it kind of has an asymptote here. So instead, let's make it have an asymptote here. All right, and this is kind of bending this way. So let's make this one bend away. And so roughly, I would give you credit if you drew something like this. And we'll call that, again, if this is f, we'll call this f inverse. And you can see it has that symmetry over the line y equals x. Last big idea. So a while back, right, on one of the slides, we did this function. And we ended up getting, I think we had minus on the last slide. It was plus on the other. I can go back and check. Yeah, it was minus. Okay. And we ended up getting this. And we called that f inverse. Okay, if you compose a function with its inverse, something nice will happen. Okay, so remember from our lesson on composition, this means plug in where there used to be an x, plug in the equation for f inverse. And we can see, okay, if we start to simplify this thing, well, the 3 and the divide by 3 will cancel. Oh, and then the 5 and negative 5 just cancel out. Let's try that the other way. Okay, if I compose the other way, that would be plugging f into f inverse. But again, we see, okay, the 5's cancel. And then I get 3x over 3, but that would also just be x. Okay, and this shows that no matter what x is, if we do f to it and then we do f inverse to it, we will get back where we started. Okay, in other words, let me just use like a simple number like 1. If I do f of 1, and that would be 3 minus 3, that'd be negative 2. And then I do f inverse of negative 2. Okay, so if I take the output of this and pass it to f inverse, I can see I'm going to get 1. So I plugged in 1, and I ended with 1. Okay, and so what happens is f and f inverse sort of undo each other. They cancel out, right? And think about it, it kind of makes sense because, again, like we talked about, this was minus 5 and this was plus 5. And this was multiplied by 3 and this is divide by 3. So f does something, and then f inverse immediately undoes all of those things, and vice versa. Okay, so the last big idea here, and this is truly the big idea. Okay, if you learn nothing else about inverses, moving on to calculus, please learn this. When you compose a function with its inverse, they will cancel out in a sense. Okay, so f inverse of x is x and vice versa. And this will be important, especially in this course. Next chapter, we're going to get into like logarithms. And we're going to see that when we compose like log base 3 with 3 to the x, that those are just going to, in a sense, cancel out. And that's going to be a really important idea. And same thing when we get into trigonometry. Okay, we're going to talk about sine, and we're also going to talk about sine inverse. And those likewise will cancel each other out. All right, so again, if you have any questions, send me an email or let me know. Otherwise, have a great day.